Welcome back to another episode of a very basic space program. In this episode, I'm going to do something I have never done before, and I'm not sure why I haven't. It's first Molniya orbit, so if you're as confused as I am, please join me. Right, first Molniya orbit. What do I need to think about? Well, the Molniya orbit is very highly eccentric and it's highly inclined. The idea is that if you imagine the Earth as a ball, the Molniya orbit is very much a stretched out orbit around the top where the satellite will spend a lot of its time above the northern hemisphere. The idea is it spends 90% of its time above the northern hemisphere. Originally, I think deployed by the Russians originally, with the idea of being able to sort of carry out communications, things like that. And because most of their territory is in the northern hemisphere, high up, it was high latitudes. It was really helpful. Things to remember: we're going to have to put 85 units on this craft. In fact, let's accept it. Thanks, Jane. Yeah, thanks for that. Right, we're going to put 85 units on this craft. It's going to have an inclination about 61 to 65 degrees. We can do that. It's going to have a minimum periapse of 500 meters. Now that's the interesting one for me, because we're not going to launch to 500 meters. 500 kilometers. So we're going to have to do that afterwards, possibly while we're playing around with this. So we're going to need a craft that's going to be able to refine its orbit a bit. So the 85 units plus that makes me think we're going to use one of our ComSat sort of constructs again, and that should give us range. This time period, we're going to have an orbital period of 11 to 12 hours. Now, that to me feels almost geostationary in altitude for our apoapses. I have never done a Molniya orbit. I have never really looked at them. So this is going to be me doing stuff terrible. Eccentricity is really quite high. So it's a very high eccentricity orbit. So we know that. So we've got a lot of things to think about. So let's go to the VAB and actually think about putting a craft together for this. Right, here is our early COM 125. I've actually reduced the payload in here to 85, so that's what we needed. We're going to put these back on. So we know this thing is potentially going to be part of the project, shall we say. We'll stick those on there like that for now. So that's one bit. That's going to give us 800 meters per second. We've got improved this, that and the other. I don't think we've got anything else we can do with it. No, there isn't. So we can actually just sort these back out and we can rename this to Molniya 1 or whatever I decide to call it. Put this on like so. We're going to need a bump stage at least, and I don't know how high we're going to be needing to go. I don't know what the delta V is that we're going to need for this. This is the problem that I have. There's a bit of me thinking 2,500 would not be a bad idea. So maybe we'll look at that. So there's that. Let's do that. Let's save this to Mol 1, not to be confused with the orbital laboratory that was associated with Gemini and so forth. So let's have a look. Let's take this off to start with, and let's see. What solids have we got? What solids do I have? I've got you. I wish you could just have a button for solids. It'd be much easier. Right, that's utter crap. So we're not using that because it's not going to give us anything. We need to try these. These would be even worse, wouldn't they? Oh, actually, to be fair, no. They are still terrible. What have we got? I really want a nice big solid, something that's going to be a punch. We could use a Nike, but that's very big. It's very big, it's very thin, and I don't really want that. So what else have we got? We've got anything chunky? I want something like I don't know. Tell you what, let's go on. No, I don't think I've done much in the way of things. Let's go and have a look in the research area, just because I think it's an easier way for us to look at that. Right, so the best solids we have are the casters, and we could actually unlock that one. That might be a bit heavy though, 3 tons for a caster. I think that might be overkill. Interestingly, we had to actually pay for that. I'm guessing because it's got some other stuff going on with it. I don't know. That's a bit heavy. We could underfuel it, but it's a big sort of solid rocket booster, and I'm concerned that'd be too much. We do have 2 of those. We've got with those which we've looked at, and they don't give us much of a punch. So the next question is, well, do we go for like a restartable engine? Do we use something like we've used before for going to the moon? And that's That's adding mass to that vehicle. That is quite significant then, isn't it? Right, there's our satellite that we're going to send up there, and we could just stick this on it. I mean, that is an option. I'll get rid of these solar panels, obviously. That's an option. We'd have to make a bigger fairing. I do feel as though that's massive overkill though, because this is just big. It's just big for what it does. What's it like for avionics? What's the mass on this? So this is 4.38, right? So what's the avionics on this? Well, 4.1. So that's not enough. So we would actually have to empty some of this. We could actually reduce the utilization. I can't. It's a balloon tank. We're gonna have to make it shorter. Oh, that's horrible. Right. So we could actually shorten this a little bit. Ooh, now 4.37. What's that? 4.1. This is going to have to go down significantly, isn't it? It's going to be a retool. That is annoying. Yeah, it's going to be a retool if I do this. Which isn't a nightmare. It isn't a nightmare. It's doable. Because it shouldn't cost us too much. How much is a retool of that going to be? 2,000. I'm willing to go with that. I am willing to go with that. That's going to give us enough sort of maneuverability, enough organization. That what is going on with the bottom of this? Where's all my things gone? Didn't I have... Right. Interesting. We probably need to turn that back to what it was on. There we go. Better. Right, I thought that this was the craft from Explorer 3, and obviously with Explorer 3 I used the orientation controls on the top, didn't I? Okay, so what we're going to do is we're going to just pull this up a bit. There we go. We could actually go a bit further, but I don't want to catch it. Right, so those are there, and that's that engine there. I think we're going to have to pull these down and that down. Okay. We potentially could actually just mount this on there without a decoupler, but yeah, we'll see. I think I'd rather just do this. So we're going to do that. I'm going to put this here onto there. How short? Oh god, it's going to be a retool on that as well. What is that going to cost me in funds? That's the problem, isn't it? Right, let's have a look. Keep going up a bit. How much is that going to cost? Oh, it's going to be a big one. Oh dear, this is going to cost a lot, right? How much is that going to cost me? Fairing. Actually, that's not bad. I could actually do with a bigger fairing. So what if we get rid of that? Let's actually be a little bit. Let's go plan forward. Let's go for 5. That's 5 meters. That gives me enough space for a bigger craft on the top of their longer, taller craft. And this has been shortened already. So yeah, that gives us a decent size. In fact, you know what? No, we're not dying for launch, are we? So 575. Okay, this may have to do a bit of burning, but that's not a problem. So what we'll actually do is we'll go big fairing. There we go. That's better. I'm happy with that. We can actually reuse that fairing. So this is going to be more one on Javelin 4. Okay, save that. Let's have a look. So we have engine up there, a decoupler. Okay, engine down there. These orientation controls, and that can actually go to there, can't it? That'd be better. That decouples. Yeah, I think that's it. I think I'm reasonably happy with that. I think that's doable. We could put some extra solids on there, but you know, whatever. We don't really have the mass allowance. We do have a bigger pad that we still haven't used. I really need to build a bigger craft, which we will have to spend some funds on, I think. Oh, actually, one thing we could do. Let's do that. I've messed that up now. It's going to put. Yeah, I knew it was going to do that. I hate the way it deals with fairings. Absolutely hate it. So those are going to go like this. I want to actually do after that starts. Right. What I could do is actually upgrade this, because we now have, where are we? Better. Oh, it's already done it. Oh, because I need to go into the research thing and just check whether our tech level's gone up, because I know we've built our new communications thing, so I'm pretty sure it's gone up. But you know what? I'm sure it'll be fine. This thing should have range to the moon, so it's bound to have range to wherever we're going. Right, so I think that's us done. It's 100 days, so let's try the tooling. What's the tooling going to do? It's going to take it down to 96. That's not much. Saving 4 days. I saved 4 days, and it cost me that. Untooled, it's going to cost me... you know what? Just tool it. It's 4,000. It's nothing. That's fine. If I was doing a perfect run, I probably wouldn't tool that there. We'll see. Right. Save it. Let's launch 2 of those. And yeah, let's go build them. And then I will see you upon the launch pad when we try and figure out what's going on with this thing. So here we are in the communications, what's it called? Tracking station. That's the word. And you can actually see we've got this little trace here so we can see the orbit. We basically just need to go into a highly inclined orbit, and then we're going to do our burn from periaps down here. That's going to be 600. Oh, it's 600. I thought the instruction was minimum of 500. So that's interesting. Is it just doing that because it can? It probably is. Yeah. So it's probably just doing it as a little example there. And it says here 39,000. Right. So that's geostationary sort of altitude, isn't it? But obviously not geostationary. Okay, so this is like a geostationary transfer burn. So that's okay. I'm reasonably happier with what we've actually built now then. Right, and this will end up as communicating with the Earth up here. I don't think it'll be able to communicate with the comsats down here because the signal won't be strong enough. But you know, we'll think about that. So right, we're going to launch and put it into there. So I don't think it matters where around our orbit we've actually launched this thing. We just need to launch it. But we may try and line it up with at least that when we're actually doing it. So I will get this thing built and then we can go for a launch. Right, here we are on the launch pad with our Mol-1 craft, and I'm just checking everything. We have got our required payload. Interestingly, we're already at the required eccentricity and we've got a periaps between the correct angles. So, you know, already partway there. We're actually going to make things worse, I think, in the next couple of minutes. So what am I trying to do to start with? Our first part of this is launching it into orbit, obviously. And let's first of all get this thing just going. But you'll notice I'm going to put my heading as, let's see, I'm going to put my heading as 20 degrees. And it's going to be a normal launch, but it's going to be more polar than normal. So there we go. I'm going for 20 because I'm going to refine this as we go up, but we're going to start off basically trying to increase our inclination. Obviously, inclination is up here. Where are we? There we are. We're at 28 at the moment, so we've got to gain quite a bit of inclination. Let's get going. That's done, that's done, that's done. Start some engines, please. There we go. Get them going, and off we go. Boost, or whatever the Russians say. Boost. Right, so we're going on up, and I feel as though I should be doing this with a Russian rocket. I don't know why. I just feel as though this should be very much a Russian rocket that I'm launching. I don't know. Possibly because in my mind, Molnier orbits are all about the Russians and things like that. So we're just going to go up. I still have the problem with this craft where these solid rockets, when they actually decouple, start to play, so shall we say, silly buggers with the boat tail and things like that. I could just remove the boat tail, but I like it, so it's going to stay on, even though it does annoy me significantly. Right, our solids are gone, and there we go. Look at that. One's still attached, and it's not the same one each time, by the way, if anybody asks. It's always a different one, and they always hang off until they get a bit higher, and then they just fall off. So there you go. It's probably going to go soon. If it doesn't, it's going to be the one time that it stays attached to the craft all the way up, isn't it? Just to annoy me. There we go. A lovely bit of... That's going to stay attached all the way up just to annoy me. I can see that already. Often it will actually induce a roll in the craft, which is interesting. So you can actually... you have to actually control the roll a little bit. There you go. Do that. And we're going to pull that down. Now I know I've turned over very... There we go. It's finally gone. Right. I've turned over quite quickly there. I didn't need to. I need to start looking at this. We're going, okay, we're definitely going up. The inclination's going up nicely. Again, when we get into orbital, we're going to be looking at where our marker is here, so that when our inclination's in the right place, we'll actually align ourselves with that marker, our prograde marker, so that we can actually not keep increasing it. So we're looking for an inclination of 61 degrees. I've actually, forgotten about turning over and doing anything like that. We just do this. Take this down to, I don't know, 25. This is a bit of an interesting craft for launch, isn't it? get the RCS ready, because of course this second stage has that RCS component to it. That fairing is quite large right now, isn't it? It's going to be good to get rid of that, because that will be adding a lot of extra weight to this. This craft, remember, sort of struggles to get itself to orbit. So I'm imagining that our sort of transfer stage at the top there is going to have to do a burn to finish off orbital burns, because I just don't think we have the Delta V in this craft. I like it. It's a nice 150-ton launcher, but it could be better in a lot of different ways. I think maybe spending a bit more time in future developing these things instead of slapping some American and Russian engines together and thinking it's going to work. This was very much a take the Javelin 3 and make it a bit bigger, and it could have been done a lot better, and I blame myself for that. I don't blame you. You should have suggested other things, obviously, but it's not your fault. You know, you're not to know. All right. Going up there, we've got engines out. Next stage, fire those engines. Wonderful. Right. We don't want to decouple or open up the fairing just yet. We're a little bit low. We could... actually, I don't mind how high I go, because we're going to actually have to gain altitude anyway on the periaps later, so it's not really a killer for us what altitude we get to. It's more the time to it that's important, and the inclination. Oh, we have gone beyond our inclination, have we? Yeah. So I have been too busy looking elsewhere. I want to pull this down. So we want the inclination to come down now. I'm going to aim for about 60. I should have chosen a value. I should have said 60. 64 is where I want to be. So we're gonna just do this until we get to about 64. I'm going to force it. I hope we haven't gone too far, actually. I think we're okay. We're going to be okay. I think we're just pulling it down now, and we can now get rid of that fairing. There we go. We could change the inclination once we're actually on orbit, but again, not that efficient, so we won't be doing that. We're going to just do this and keep going like that, and then it will soon get ourselves into a nice range. And what I'll just do is we'll just pop it just to the side there. There we go. And then I'm going to pull this down a bit, and we'll pop this actually just about there. There we go. So that's going to, you see, because I'm just above where my marker is there, that's going to just keep dropping that inclination a little. I'll have to keep that in mind, because it will keep dropping. So what I will do is actually pull that down a bit, and we'll just sit it just there. So the inclination is now okay. We're outside of the atmosphere that Kerbal says we have, and we're just going to burn along now. So I'm going to actually do a bit of physical time warp, because I can do a bit of physical time warp, get that going. I don't know if you want to see a launch like this. This is sort of part normal launch, part trying to actually prepare for other things. So I'm keeping in mind a lot of stuff going on at the moment. This is going to keep going down. Again, if I get to 64, that'd be a really nice inclination. Again, it puts us right in the middle of the range, and means that if we do any odd burns later on that mess up our inclination, it's not going to be as big a problem as it potentially could be. But we'll see. So we've got, what, a minute 40 left on this. Okay, I think we are going to need this stage to fire, aren't we? So that's annoying. Is this actually active? Activate those avionics. That's a good idea. We're going to zero that. There we go. And this thing is now going to have to fire, because I do not think we're going to have enough Delta V in this first stage, because we've now made this quite heavy, this section, obviously. So that's going to be fun for us, isn't it? It might get us into orbit. I don't think it's going to, and if it doesn't, it will. Actually, you know what? We're actually close. Ooh, that's very annoying. There we go. That is really, really annoying. And then we could actually just cut that off there. Yeah, we go. Right. So now we're in orbit. Let's put ourselves onto the normal. And let's have a think. So we are the correct inclination. Eccentricity is out. Periapsis is never going to be right at the moment. But we have got an apoapsis that's a little bit higher, so that's okay. Argument of periapsis. So now we need to have a look on our little map here, and we need to go right. We need to do a burn. We need to do a burn right down here. I want to do it right at the bottom. We're not perfectly where I want to be, but we'll do it at the, if we do it at the periaps, which is not there. Alright, if I want to do it about here, actually, add maneuver, and I want to take that up to about where that is. We're going to just do this. We'll probably end up going to have to do a lot of maneuvering around with our actual probe when it's done. That is not perfect, is it? I think I might want to move this back a bit. Just like, there we go. That's it. That looks better, doesn't it? Not perfectly aligned with that one, but it'll do. That's a start of it for us. And of course, yeah, 2.5 kilometers per second, or 2,500 meters per second. That's a big push. That is a geostationary transfer orbit. So you know we're actually towards the point now where we could do some geostationary stuff. I think we did one geostationary test satellite, I think, early on, didn't we? And now this is going to be again doing that. So I actually have to look at our geostationary contract and see what we actually did with it, because I should have just used it for this. I don't know why I didn't think about it. Well, that's a very silly thing to have thought, isn't it? I should have just used it for this. Right. Let's see. We're going to put ourselves on the node. Now, right now, we're actually using orientation control from our top satellite here. It's got little orientation controls because we don't have orientation control down here. These are pretty much almost empty because we have actually got fuel cross-feed here. So imagine there's a little pipe that runs down, and that is primarily just to start these engines because I need them to be, it needs to be restartable. If this cross-feed wasn't on, these thrusters would not fire yet, so it's not actually a big issue for us. It probably would have been better without them on, actually. I don't know. I do wonder whether cross-feed should add mass to the decouplers. It might even add it, and I don't even know. If it does, please tell me, because that's actually quite interesting. Right, let's warp around to the correct point. Now we should have signal because we've got that nice communication system. So you can see, yeah, we're jumping through. Let's have a look what we're jumping through. We are jumping through. Give me details. You're not going to tell me. You're not going to tell me, are you? Often it would tell you. Oh, so we must be just direct. We must be direct. Yeah, direct to Space Center. Okay. Well, that's nice. That's a good thing to have. Right. So now we're going to be looking at these things. We don't need to worry too much about the massive accuracy of this. We want our eccentricity to be good. Currently it is. Yeah. No, it's an interesting one. There's a lot of things to sort of moving parts to be monitoring with this, and so it's something. Molniya orbits are something that I have very much avoided in the past, and I probably shouldn't have, because if you're able to do geostationary, your craft are pretty much able to do Molniya orbits. It just takes a little bit more finagling. You know, hats off to the Russians for doing this, because it does take a little bit of planning. You have to really be thinking about when you're going to do your burns and stuff. So let's have a look. Come on, are we ready yet? Are we ready? Come on. I actually want to speed this up a little bit. Start the burn in. Let's go a little bit more fast. More fast. Speed is good. Yeah, there we go. Right. So we're gonna start to do that. We're gonna wait until our engines get settled, and then we're gonna fire it up. There we go. And that's gonna stay on now. Remember, this engine is active. I didn't deactivate this engine, so if I'd have actually put any thrust on at all, it would have misfired and potentially gone. Right. Argument of periaps is correct now. Okay, that's good. What else have we got? We've got to look for our inclination. No, we've got to look for eccentricity. Our inclination is staying perfectly fine. That's good. Just didn't get down to quite where I wanted to. You can see our eccentricity is going up. We are above 500. That's perfect, actually. If we're above 500, that means our periaps is going to, our periaps is going to be over 500. So now we're just looking at that eccentricity. And the time. Time is going to be king, isn't it? So we've got eccentricity, needs to be over 0.7. So as long as it's over 0.7, then we're going to be focusing on the orbital period. Orbital period needs to be 12 hours. That's what we're looking for. And we could probably speed this up. I don't know. Let's get ready, because I'm concerned that we go too far and we end up escaping the Earth's sphere of influence. Although I don't think we have. Well, we maybe do have enough fuel on board to do that by accident. So I just need to keep that in mind. So our eccentricity is up at 0.4 now. Okay, we've just lost something. Something just clicked. I don't know what clicked. Something changed on the contract screen. Perhaps this is no longer. Oh, it's still not above that. Okay, we're going to get there soon though. Right, we're looking at orbital period. Once the orbital period's okay-ish, or the eccentricity is okay, we can play around with it. I think we're going to have to bring our orbital period. I think we're going to have to bring our periaps up a little bit, actually. I think, yeah, we're actually falling right now, aren't we? That's the problem. Oh, so we're actually going to be doing this burn at the worst possible time, right? So now we have our eccentricity is okay. Orbital period needs to be stopped. There we go. Oi, what happened there? Something happened. Something happened. Why did we start spinning? That was not healthy. That was not as. Did we get to the? I think I actually overburned, didn't I? That's what it was doing. It was trying to fix it. Now, I don't need this stage anymore. I don't think we've got enough Delta V in the other one. So goodbye. Right. And now what I've done is I've actually created a situation where I haven't got my avionics on. Hello, come here. Avionics. Activated. Thank you. Right. What we're going to put you? We're going to put you normal? Let's put you normal for now. Right. So we've got a few things we need to do. I need to, first of all, let's check. Oh, we actually stopped it perfect. So we've got a nice orbital period, but the second I bump up that periapse, that orbital period's going to go too high, I think. So we're going to probably do a couple of maneuvers here. First off, we're going to go up to here. Wait until we get some sort of orientation. There we go. We're just going to go up to there. Have we actually got electricity? This is where I find out my electricity is going to go. No, it's got electricity. Okay. Right. There we go. Thank you very much. I want to be prograde. So what I want to do up here is just tap. Just the slightest of tap. In fact, you know what? Go normal. We're going to use the RCS for this. Can I do a translation? Yeah, I think I can. I think I can translate this up. There we go. This is going to be cheeky. There we go. So I just translated it. I used the translation controls because if I fire that little engine there, even though it's got very little thrust, it's going to be enough. Oh, it would actually be enough to throw us completely doolally on this. Where is the sun? There is the sun. Right. So we're going to do that again because we've lost it a bit. Oh, I want that one. There we go. There we go. So there we are. That's that done. We can actually do that a bit more. Let's give it a bit more because we've got a little bit of leeway with the time that we've got on there. So everything is okay, and now he's got to wait for 2 minutes. So what we'll do is we'll do a little bit of timey-wimey warping, and that'll just a bit more because for some reason physical time warp is not making that clock go down very quickly. Right. So there we are. We should have. We've got signal, we've got signal, we've got signal. Where's our signal 2 is the interesting thing. Let's have a look. Are we actually connecting to anything else? We are connecting to a lot of things, but are we? There we go. It is able to connect to ECOM. Oh, that's good. So we do actually have a connection between this and ECOM. So this is covering the North Pole now, which is really nice. So that's another bit of our communication system that's going to work, which is brilliant. Love that. Task is complete. You notice 2 things happened there. Number 1, the task completed over here, but number 2, we actually lost that the orbital thing that we had there. So that's good. So that's just going to sit like that now. We can turn the RCS off, and we're done. So with that episode, that episode. I'm talking in the past tense now. So we'll get rid of these things here. Right, that is completed. 67,000 in the bank. It cost us a big chunk to do that. We've got a bit of science to spend next time. Thank you. Yes. No, come on. Anyway, got a bit of science to spend next time. Got up to 420,000. I think we need to go back to crew. So maybe next episode we'll do a couple of contracts just to use up those craft we've got. See if we've got any new crew available that we want to hire. And yeah, so from me, until next time, have a great one.